Quick riddle. What did the 12 apostles make? What did the 12 apostles make? They made a dozen. I know, you didn't like that one. I bet nobody got that. Tell me if you got that one. Maybe you've heard it. If you haven't heard it and you got it, I'm impressed. Okay, so we've skipped examples 13 and 14. And again, we have to talk about the alternating series test. We'll get to that. And then I'll have you guys go back and do those two examples. But we've talked about the tests that all the terms need to be positive: the limit comparison, direct comparison, integral, and also p-series. But don't forget what that acronym was: piled high. Okay, so the PILD. Those are the 4 tests where all the terms have to be positive. So those are the tests that, if by chance you get a series that does have alternating, it is an alternating series, alternating in sign, then if you just make all the terms positive, use one of those tests, and if the absolute value of the series of the nth term, let me back up. If you take the series and throw out all the negatives, just make all the terms positive. If that particular series converges, then the test for absolute convergence says that it does converge if all the terms being positive, if that particular series converges. So we're going to do an example down here, and so you can see that. But there's this terminology called absolute convergence. The next page is going to show it a little bit better. But if a series converges absolutely, then the series converges. Okay? If the series doesn't converge for all the positive terms, it still might converge if the terms are negative, and we would say that that particular series converges conditionally. I've never seen a problem like this on the AP exam. At first, when you learn this, it seems a little bit odd. We'll talk about it in class a little bit more. But just kind of go with it here. We're going to take a series, and we're going to take the series and we're going to make it positive. So this series has some negative terms. In fact, every other term is negative. So we're going to test the series. And what is this? This is 1 over, we should do that. This is from n equals 1 to infinity of, what is that? 1's in the numerator. We have 1 to infinity, 1, 2, 3, 4. So that would be n squared. But then we also have this negative 1 to the, what would that be, to the n plus 1. Okay, because n starts at 1 here, and n plus 1 would make that an even first power of a negative 1, and therefore the first term would be negative. So this is the series that we're actually testing. But let's go ahead and throw out the negative and test this series. N equals 1 to infinity of 1 over n squared. Well, this converges because, why? Well, this converges because it's p-series. Oops, p-series with p equaling 2, which is greater than 1. So as long as that exponent of the n is greater than 1, then the series converges. And so we say, therefore, the other series from n equals 1 to infinity of negative 1 to the n plus 1 over, or times 1 over n squared converges, and we say it converges. If you're ever asked, how does it converge? And you might see a multiple choice problem on this. Converges absolutely. In fact, take it back. I do remember seeing a couple problems like this. Converges absolutely. Okay, and that's what we say. What happens if the absolute value, the series with the absolute value, all the terms positive, diverges? Well, it still may converge, but it would converge conditionally. Okay, and so the conditional convergence would be the infinite series conditionally convergent if it converges, but if all the terms are positive, that one does not converge. And it just dawned on me that the series 1 over n from n equals 1 to infinity, that series here diverges. Okay, but if we make half the terms negative, negative 1 to the, let's say, n plus 1, multiplied by 1 over n, well, this series happens to be, what is that? 1 minus 1 half plus 1 third minus 1/4, you'll see later on that this series converges. Okay, and if you were asked how, we would say that the series converges conditionally. Okay, conditionally. So it converges conditionally. This converges absolutely, because when all the terms are positive, it still converges. All right. Well, when all these terms are positive, that diverges, but the ones that have half the terms are negative, well, it converges. So it converges conditionally. All right. So that's 5.5 minutes. Let me, I don't know. Let me stop so I can make sure I know what I want you to do.